There it is. Alright, welcome to my kitchen where I'm making my famous chicken noodle soup. What I'm about to do is I'm about to sample my soup. Delicious. And it reminded me of what our next section is, which is sampling. What sampling does is we take from the population just some of those people and we try to get those people to represent the entire population. Well, I'm doing the same thing here with my soup. I don't eat the whole bowl, the whole pot of soup. This is for my whole family. But I need to know what the soup tastes like. So I take a sample of it. Well, we do the same thing with people. Well, instead of asking everyone, surveying the whole population, we just take a sample. But we want that sample to be a good representation of the population. The same thing is, I want that taste to represent what the whole bowl tastes like. I don't want to just take it off the top here, because then it might be too salty. Might not get all the ingredients. So I have to mix it up real well, scoop in, get a good taste. Let's see if it's good. And that's it. I'm going to pour out the noodles, pour in some broth. There you have my famous chicken noodle soup. I'm out at Ridley State Park, out for my morning run. Just getting done, probably about a 5-mile loop here. And we're going to be talking about sampling again. And this time, since I'm in the middle of the woods, why not talk about if I wanted to sample a few different types of trees. You see, they do number their trees here. And we're going to talk about a simple random sample. We're going to talk about convenient sampling, stratified, cluster, systematic. And we'll do that when we get home. We'll use a whiteboard and I'll give you a demonstration. Just remember these nice, beautiful trees out here as I walk through the woods. We'll see you in a little while. All right, I drew a nice little forest back here. And you will see how we're going to do a simple random sample, which I was talking about before, because we want our sample to be a good representation of our population. Usually we stick with a simple random sample. There's other important ways of sampling. Some of them you got to be aware of that they could have bias in there. And what bias is when something doesn't represent your population properly. That's exactly what it does. Your sample in some way favors one group or another. So for a simple random sample, there's 3 things you have to know. First off, we got to obtain a list of all the people in the population. And if that's not available, it's called something called a sample frame, which is a list of all the people that you have. In this case, it was trees. We're talking about trying to find, let's say, 10 trees. And we're going to test these trees by giving them a new fertilizer or something like that. And you want to see if the new fertilizer works. Well, you don't want to just pick the first 10 trees you see, and because there are so many factors that can happen that can affect this. So what we do in a simple random sample is this. We number everybody in our population. So we would number all the trees. So we would sit there and we would number all the trees. So you would number all the trees right here. That's the first step. So let's say there are 978 of them. I number them from 001 to 978. Then what I'm going to do is I'm going to use something called a random number generator here, or a random number table. We use our calculator. And then what I do is I'm going to find the first, and it says nth number of trees in our sample. Let's say I wanted to find 10, so I'd find the first 10 numbers that fall within the range of 001 to 978. And they're the 10 I would use. And I'm not going to use the same tree twice, so if I get a repeat, I don't count that. And in a simple random sample, the important thing to know is every tree has to have the same probability of being chosen. And every possible grouping of 10 has to be possible. So I'll show you how to do a random number table and random generator. After going out and we numbered all our trees, there were 978 trees. We went up and put a number on each one of them, let's say. And I put the numbers from 1 to 978. Why do I have 001 instead of just the number 1? Is because I'm going to be using this random number table here. And however many trees you have, in this case 978, if I only had 10 trees, I would go from 01 to 10. If I had, actually I come from 0 to 9, it's a whole other story. But let's say I had 20 trees, I would go from 01 to 20. If I had single digits, if I only had 8 trees, I would go from 1 to 8 and number them accordingly. Anyway, so I number each tree from 01 to 978. Then I start anywhere on the random number table. You can just, most of the time you pick a random spot. So this is where I'm going to start right here. And then what I do is I break this into groups of 3. 3, 3, 3, 3, and so on. Now, a lot of times they'll tell you where to start. This way we all get the same answers. A lot of times they'll tell you to stop and start in the upper left-hand corner of the first row or whatever. They'll tell you where to start so that way all the answers come out to be the same. Otherwise, how do you know what they really did? And when someone asks you a question, they're not going to be asking you just to find 3 numbers or 10 numbers between here. What they're going to do is say, how would you do it? And then you have to describe the entire process of obtaining a list, labeling each tree, and so on and so on. So let's look at this here. And if I go here, the first one, 279 right there. Yeah, that falls in my range. So I can write 279, and that's the first tree I'm going to use in my sample. I said I wanted 10. I'm not going to do them all. 930 is another one. That's fine. That's in my range. The next one is 495, 266, and so on. 495, 266. And you keep going until you get 10 distinct numbers, 10 different numbers. You don't want the same tree twice. And you just keep going. If it's not in your range from 001 to 978, say I had 980, I don't use it. I just simply skip it until I get 10. So that's how you use a random number table. We can also use our graphing calculator, which goes like this. It's just the same exact process, except what I'm going to do now is I'm going to do I'm going to do math, and I'm going to do prob over here. That means probability. I'm going to do random integer, which is number 5. Starting at number 1. I'm ending same as before. I'm going to end at 978. And then down here, I want it 10. And let's say if I want 10 numbers, a lot of times I don't just take 10. In this case I can, because there's such a large range. I doubt I'm going to get a repeat. But if I have a smaller set of numbers, a lot of times I'll just pick a bigger number, like say 20, and just the first 10 distinct numbers. Let's see what happens if I hit enter twice, enter, and here they are. And here's your 10 numbers that represent your sample. Now your numbers should be different than mine. If they're the same, we could have the same, because sometimes if you don't reset if you reset your calculator, they could be the same. So I find 10 distinct numbers. I go find those particular trees, and they're the ones I'm going to use for my experiment. You can do this for surveying, things like that. That's a simple random sample. After the simple random sample, which I showed you how to do, that's the one we use most often. The only other two that people really get confused about are clustering and stratified. And once I show you the difference, you'll understand it's really not that difficult to tell whether it's a cluster or stratified. There's also multi-stage where you're using several of these different types of sampling techniques. You'll see in the book there's convenience. That's just that you're what's easiest for you. It's exactly the way it sounds. You will have systematic. You just number every fifth person that comes up. You give them a survey to take. Those are real straightforward. These two are the ones that people get confused with. So let's talk about first stratifying. What I do is first I break these trees. I have my entire population. Well, say they share some characteristic. In this case, let's say I have pine trees, maple and oak. Well, what I do is I break them into these groups first. I break them down into groups, strata. That's what strata means. Some sort they share some characteristic. Then what I do is I do a simple random sample inside each one of these. And let's say I took 5 here, 5 here, 5 here. Well, then I took all of these, and these 15 trees make up the sample I'm going to use. All right, so that's all you do is you break them down into groups. You do a simple random sample among each group. Let's say I take 5, and then I use 5 from each one, and that becomes my sample, and that's stratified. Now in cluster, I didn't need to erase the whole thing, but cluster, they also break them into groups. A lot of times you hear about like geographic area and things like that, but you can still say, you can break them down into groups similar to what I just did, where I say, all right, let's look at the pine, maple, and oak. And then what I do is I break these down into these 3 groups. I have 3 sets of trees. Well, then I do a simple random sample, and I pick one of these. So I do a simple random sample, and then number this set 1. I don't know. I just go 1, 2, 3, and then let's say I pick 1. Well, then all of the people in this group are the people in my sample. So essentially what you're doing when you're clustering is you're breaking them into groups, and then you're doing a simple random sampling, picking one of the groups. In stratifying, you're breaking them into groups, do a simple random sample among each of the groups, and then take each of those samples, put them together to make one group, and that's your sample. And that's really the difference between clusters and samples. They're the two most difficult. They're the ones people have the most difficulty distinguishing between. So if you understand that, you're doing pretty good.